Okay, my name is Philip de Melo, and today I would like to discuss with you a very important topic. It's big data analytics for public health and health care. So, why it is important? Because I found out that many organizations, healthcare, public health, they're eager to adopt big data paradigm, big data algorithms, but some of them believe that it is too hard, too difficult. They don't have means, they have no professionals to work with big data. Although we know that from 80 to 85% of all data we record in public health and healthcare refer to big data. So that is quite important. What I would like to say that why it is also important because our inability to efficiently working with big data leads to $300 billion losses to national health economy annually. It's a huge, huge number. And as you know from my previous lectures, I'll also refer to these numbers. The National Institute of Health published some forecasts saying that 10, 15 years from now, we basically won't be able to use traditional algorithms that we use now, working with new challenges. And therefore, it is, of course, important. And I would like to show that actually, and I would like to get across that message that it's not difficult. And I will show you not only some pictures here, but I'll also show you some data, and we'll see how it is fascinating to work with big data to get results. What is different from traditional algorithms that we get used to work with? So, as I said, that big data describes information too large and too complex to be analyzed using traditional techniques. Mostly big data is unstructured and not organized meaningfully. 85% of recorded health data now is big data, so we need to train students, we train personnel to work with big data because talking to various organizations last year and this year, I found out that sometimes they hire a new personnel and they come and they cannot work, they can't apply their knowledge to challenges, to problems that currently public health agencies, healthcare organizations, clinics, NGOs, they face. So therefore, it creates misunderstanding, frustration, and so forth. So that was the goal of my lecture today, that it's not difficult to work with big data. And this is, it's a very fascinating field, and not only big data analytics, but big data science. It opens new horizon, actually will revolutionize public health together with our algorithm that were developed recently. Now, traditional data is usually the structured data. What does mean structured data? It's a table that has rows and columns. Rows we call observations and columns we call features. So traditional data is usually the structured data. In a traditional database system, a centralized database architecture is used to store and maintain the data in a fixed format or fields in a file. For managing and accessing the data, structured query language, SQL, is used, and sometimes we call the data, structured data, just SQL data or SQL database. And traditional data analysis techniques involve using statistical method and visualizations to identify patterns and trends in the data. Now, what actually the data analysts in healthcare and public health are doing, and what requirements we pose on them. So some fundamentals of SQL, but in many instances, I just observe that the data analysts, they just don't need actually to do any programming. So they just need to have some fundamentals of descriptive statistics, very, very simple. And they do data visualization. So use lots of Tableau prep, Tableau Desktop and Power BI, for example, which is the same thing. They have very nice pictures, very nice charts, and they do reporting. So this is a data analyst. So data analyst, we do not require the data analyst has profound programming skills. And this is a typical data set structured. It is SQL data set that we use, let's say, in public health. We have here, for instance, we have here features that is precipitations, humidity, and how they affect, let's say, public health. And we have here different observations made, for example, September 9th, 2024. Then we have other data. Now, first of all, what a data analyst is doing data exploration because he or she has to know where the data come from and what information they have. In a clinical setup, they need hospital information, patient demographics, hospital stay information. We call it LOS, length of stay. We have billing insurance information, some miscellaneous diagnostic information, the drug cost, and this everything is quite straightforward. In public health, we also need to know where the data come from. They come from different, as you remember my lectures, we have different categories, like 4 categories. It is D, it is disease, it can be even genome, it has electronic health records, it has HIE, it has different repositories, registries, and immunization records, and so forth. And then we have H, it is host, we have E, it's environment, let's say climate change, air quality, water quality, and so forth. And we have then SM, it is social media that we use in public health a lot. So this is give us many things, and maybe we can maybe have a special session. Like I will show you how we use social media now in setup of let's say even big data. Now, data exploration, for instance, we have a typical this age groups. We have race, length of stay in a hospital, total charges, severity of illness score, mortality status, disease code, and we can have wonderful charts, let's say, using this Tableau. We have, for instance, this is patient, this is percentage of mortality, it is respiratory diseases, it's real data. And we have various things that we can include then in our report. So that is exactly what a data analyst in healthcare is doing. And then he is doing, as I said, data exploration, works with structured data mostly. It does minimum or null programming. It's very rare to find out that the data analyst is doing programming. Data wrangling can be done using, for instance, Tableau Prep or other tools. We have many of them. And then it is data visualization. It's very important, data visualization, because data visualization actually is an essential part of the report that he is in. Now, the big data analyst is completely different. Besides data exploration, he works with unstructured data. And this is what a traditional data analyst cannot do that. He builds a big data information system because remember, I told that big data is an information system. It is not just big data, say that we can use visualization right away. You have to build an information system, you have to build a pipeline, and he needs to have, even data analyst, big data analyst has to have a strong programming skills, let's say Python, Java, R, C++, it depends on the program. And he needs to know or she data integration from different sources and data visualization in real time. So he has to build a pipeline. So it's a big difference between big data analyst and just data analyst. And big data analyst is a profession that it is highly requested by current situation in healthcare and in public health in this country and also in other countries. I visited this summer various companies in Europe, and everybody, they asked that if you can recommend somebody they can hire students who can do big data, become big data analyst. Because as I said, traditional data analyst is not enough now. It's not enough. We change, time goes by, and we need to go to a higher level of knowledge. Now, what happens is big data scientist is another area, and is a much higher than big data analyst. So he has to have, or she has to have, strong knowledge of data integration, real-time multi-stream processing, data visualization in real time. This is a part of data analyst. Then he has to be able, or she has to be able to apply machine learning techniques, data mining, predictive modeling to big data paradigm. This is very, very important, and I will give you next lectures. This is absolutely fascinating new field, and you can see that we can extract lots of more information from big data compared to traditional data sets, although we will not spend more time at all. So that is wonderful. Now we will use retrieve information for building accurate decision support system in public health and healthcare. So why this is very important? Because when we build this pipeline that can respond quickly to the requests, we can give a very accurate, much more accurate prediction to and make a much more accurate decision support system that can be used not only in healthcare but also in public health to predict pandemic and outbreaks. And I will show you some very interesting examples how we can work with COVID data that we didn't have these algorithms even 5 years ago. So I will show you how it works, how they work very well. Now, as I said, that many companies that in organization, healthcare, public health, we just have this statistic. So 52% they complain that the big data is too complicated. It's not. We just need to pull off, and it's completely different. We need to restructure the whole thing, and it is completely different, very sophisticated. So we just need to wait. And that is a thing that I, of course, disagree with that. And I will show you that it is not too complicated. That is the objective of my today presentation. And I believe that after my presentation, you will be able also to start working on big data analytics and consider real world situations. Now, big data's second group of companies think that big data requires sophisticated equipment and trained personnel to maintain hardware. It is also not true, because we can use, for instance, cloud technologies. In cloud technologies, you don't need to buy anything. And you have trained personnel already who will be doing this work in clouds. And the only thing that you pay is just time you spend on the problem. So you don't need to buy any sophisticated equipment. What I agree with, it is acute shortage of qualified personnel in big data health informatics. I found some statistics saying that out of 100% working in companies, data scientists, data analysts, less than 5% only people can professionally work with big data. And of course, this number is not enough. And we need to bring to workforce in public health informatics and technology more professionals who can work from day one on real world problems. Now, what I would like to say that in my previous lectures, I explained what does mean VS Code. It is a platform you can download using this link. Don't use other links. This is a link that will install you right away the VS Code. And this is a wonderful platform, wonderful algorithms that you can store data. You can install new algorithms. You can do some processing. You combine algorithms. So many things you can do for free. It is free, open source, and I use it all the time. It is VS Code. Now, I also explained to you in my previous lectures what does it mean Docker, because Docker, it is a cluster of containers, and with very useful algorithm, which we call Kafka. And Kafka is a just you can consider it as a data repository, and it is data repository quite different from let's say databases, data warehouses. You can work with Kafka. It's very flexible. You can, for example, integrate the data. You can separate features. You can do many, many, many things. And in big data, I use Docker all the time. So you can install this, and I already explained to my students how to use the Docker. And this is, they didn't find it is difficult at all. It is very, very good. And then we need to put a programming code, Python. It can be very easy code, and I'll show you, and to visualize the data. So the whole thing, it creates a new pipeline. So we don't have pipeline in data analytics, but traditional data analytics, but we have a pipeline in big data problems when we try to solve them. So then we are going to build the pipeline, and as a pipeline, everything is moving in time, because in traditional, everything's static. Here is, and you can, for instance, do plotting at different intervals. For example, every minute, every hour, every week, whatever. It depends on your problem, but you don't need to worry about it. Just will do it automatically. So this program, what I showed you, you can build your code. It is easy. You can just do visualization in different times, and it will do automatically for you. Okay, so this is the code, what I did it, but it depends on your problem. But when you run it here, okay, then you can have the data that coming with some interval. This is, for instance, how temperature affect a health risk factor. Okay, so then we just started, and with some interval of time, we have this, we have that data coming in and in and in, and it goes to infinity. So I just stop here. Now I would like to show you the how this algorithm works. And for example, when we put it here, we need to run it. Okay, and when you start running this, you have different data. You see, some with some interval. Okay, and you can do forever. This will just give you automatically all these plots, and you can compare. And with doesn't matter how many data here, and with what kind of velocity they're coming in. So it is typical big data pipeline that will give you results in time. And this is big difference the between the traditional data analytics, when you have just one graph, with many using the big data paradigm. So it will be a continuously working until you stop receiving data. All right. So thank you for your attention, and I will talk to you later when we discuss data science of big data, and you will see how very interesting, very important information we can retrieve from big data compared to traditional data. Okay, thank you.